In this lesson, we're going to be talking about attack countermeasures. So we're going to talk about some countermeasures for network attacks and specifically some flooding attacks. So it's useful to know countermeasures to attacks, partly because as you're working with your target as part of your engagement, you're going to want to educate them on the way to mitigate the problems that they have. That's where your best value is going to come, is from being able to help them solve their problems. It's not really useful for somebody to walk up and say, hey, look, you've got a door that I can break into easily. What's going to provide them some benefit and some value is to say, hey, look, you've got this door that I can open really easily. And by the way, here's how I opened it. And even better, here's how you can fix it so nobody else who may have more nefarious schemes in mind is going to be able to attack your door. So let's talk about from a Linux perspective here, because this is really useful to know. Let's talk about IP tables, which is the firewall software that is part of most Linux systems. And if it's not actually part of the Linux system that you've got, it's certainly something that you can go get. So this is a list of IP tables rules, and they look a little bit cryptic and a little bit mystical perhaps, and maybe a little bit confusing. But once you know the basics, you can start sorting out what it all means. First of all, IP tables rules are created by running the IP tables program and either adding or inserting rules or making changes to policies. So at the beginning of every line here, you'll see IP tables. This isn't a rule per se as much as it is a command and a set of parameters that's going to put a rule into place in memory for the Linux kernel to obey as it's looking at network packets. So the first thing I've got here is just a flush. We're going to flush all of the existing rules. Now we've got 3 policy statements, and there are a number of different chains and tables that you deal with IP tables, and that's where it gets a little confusing, is chains and tables. And what we've got here is 3 different chains, and I've got an input chain, an output chain, and a forward chain, and I'm going to set a policy, that's the -P, that I'm going to drop everything. So by default, everything through this IP tables firewall is going to get dropped. Then on line 5, we start doing some specific things. So with this one, I'm going to say on my input chain, in other words, packets coming into this system, anything with a source address of 192.168.1.0 with a network mask of 255.255.255.0. So those 254 or so hosts in that network, I'm going to say accept those. The next rule is a useful one to prevent attacks, because often you'll get spoofed packets as part of attacks. And here's a packet that you're never going to see on the open internet. It's one of the RFC 1918 addresses, and that RFC, request for comments, defines a series of addresses that are for use on private networks, and by convention, those addresses are not routed. So on the open internet, you're never going to see the 192.168 block, you're never going to see the 10 block, and you're also going to see a range of addresses starting at 172.16. So these next 2 rules on lines 6 and 7 here are both about the RFC 1918 addresses and how you would block messages from those addresses from coming into your system, because if you're not using those on your local system, then you're not going to see them, or you shouldn't see them as part of normal day-to-day activities. Now, I've been using source addresses here to specify rules. I can also specify interfaces. If I've got multiple interfaces on a system, let's say I've got an ETH1 and an ETH0, and my ETH0 is on my internal network, I could specify that on ETH0, if I see a source of 192.168.1.0/24, I'm going to accept it. Similarly, if I had an ETH1, I could have that rule say -I ETH1 -S and then the network address, and I could do a -J drop. because outside of my internal network interface, I should never see that address on the external interface. So the next couple of rules are all about allowing for pings to go out. So I've got an echo request on line 9 that's allowed to go out, and then I can allow the echo reply back in. Because I don't have any state associated with that, any echo replies are going to be allowed back in, whether they're attached to an echo request or not. So this could open the door to some flooding attacks with echo replies. Now, the next rule is where I start getting into some state rules. You can see that on line 11, I'm allowing destination port 22, and I'm going to match based on state. So IP tables keeps a table of state flows where if I am sending an SSH communication out, then it knows that that's established. So I've got an established connection through the firewall because I originated it, I allowed it through, and it now knows that it has an established connection. So on this rule on line 11, I'm going to allow a new state and an established state to go through, and I'm going to accept that. And on my output chain on line 12, I'm going to allow established messages through. So what this would be is if you've got the firewall sitting in front of an SSH server, I'm allowing new and established messages into the network, and I'm allowing established flows out of the network. So the next one, we start getting into rate limiting. On line 13, we're doing some rate limiting to the HTTP port or the web port. So I've got my D port is 80, that's my destination port. And on the M, I'm doing a limit. And so I'm going to limit that to 25 connections per minute, and I am able to burst up to 100, and I'm going to accept that. So anything beyond that isn't going to be allowed. Anything beyond that rate limit is not going to be allowed, and that's going to help prevent flooding attacks against my web server. So the next line on line 14, I am doing a similar sort of thing. I'm allowing related or established messages through, and I'm doing a limit of 50 per second with a limit burst of 50. And that is not based on a particular port. That's just in general over the entire interface. Any packet that comes through, I'm going to do a rate limit on it. So another thing that I can do to protect against network attacks is I can drop messages with an invalid state. You can see on line 15, I'm checking against state. If the state is invalid, then I drop it. Something else that's going to be useful is the ability to log. So I've got a bunch of things, and maybe I don't always want to drop them. I want to log them and send up alerts so that I can see what's actually going on. In line 16, I'm doing something where anything with a source address of 42.42.42.42, I'm going to log that no matter what port it's going to, no matter what port it's coming from. I don't really care about services at that point. I'm just looking for anything from that one IP address. I'm going to log the connection request, and then on line 17, I'm going to drop it because I don't want to just log it, although I do want to alert on it. I want to drop it as well. So IP tables can be a really effective tool when it comes to attack countermeasures and preventing and protecting against network attacks like flooding.